Save.
Hey, everybody. Does anyone have any questions? This is a lunar eclipse. Here it goes. Sorry. No, okay. All right. I'm going to move my. Oh. See what I'm doing. All right, guys. So no questions from any homework or anything? It's a little difficult to believe, but okay. I just finished creating everybody's. I think I got almost everybody's 1, 1, 1, 2, 1, 3. Maybe if you snuck something in just this morning, then I might have missed it. All right. If there are no questions from any homework or anything, I'm going to talk about how the quiz is going to work. And then we're going to continue. Oh, I do need to finish that worksheet, right? Where's that worksheet at? We can do that first thing. Let's see. Where'd you go? Oosh, that explains that. I'm not in the right class. Good job, Jeff. All right, let me see what I can do. Let me close that. Let me come over here. Let me get out of there. All right, guys, let me show you. Let's talk about how this quiz is going to work. I think let's start there. So I'm going to show you, this is not our class, but I need to show you a different class just so I can, I'm not going to show you your quiz, so don't get too excited. So this is my pre-calculus class. So it's going to basically look like in Canvas, there'll be the tutoring stuff, and then there's going to be a quizzes module, right? You can actually see this if you go to our class, you can see this. It's just, it's locked right now. You can't see the quiz, it's locked. But when you click on the quiz is going to open after class today. When you click on the quiz, you'll see a little intro, right? This is not our quiz. This is my pre-calculus class, so don't read this. But you'll see instructions up here. When you hit take the quiz, you'll see your time start to run down. You can download a copy if you want of the quiz. You don't have to. You can just kind of do it on a sheet of paper. Doesn't matter. Or you can download it, print it out, do it on the sheet of paper. When you are done, do you see how there's a text box underneath the quiz? It actually doesn't matter what you type, but I ask you to type the time that you're done. And then you're going to hit submit quiz. Bam. Then you actually have to turn the quiz in. You haven't turned the quiz in yet. You're going to scan your quiz, all the work you did, and you're going to go to where it says submit quiz 1 here and turn it in just like you've turned in homework. I know it kind of sucks that you have to get the quiz from one place and then go turn it in another place. But oh well, that's the way it works the best. Is everybody understanding that? So let me show you our class real quick so you can see. Oh, let me see, where am I? Dashboard. So if you go right now to our modules, you'll see our quiz right here. But when you try to go see it, it's locked. Until 3 o'clock today. So at 3 o'clock, it's going to open. I'm giving you 50 minutes to do it. That should be plenty of time. It's only about the definitions, and it's actually, I'll tell you this much, that has nothing from section 1.4 on it. You understand? 1.4 is not really that crucial. You just have to do it for homework. So you go here to get the quiz, and then you'll go here to turn the quiz in, just like you do with homework. You scan it and you submit it. This is locked right now, but you'll see. Okay. Any questions about how the quiz is going to work? So it is a timed quiz. It's due tomorrow at 3. No, stop it, Jeff. It's due tomorrow at 9 p.m. That should be plenty of time. The minute you start it, you got 50 minutes. Everybody with me? And when you're done, you need to submit it immediately. If you're done and then you submit it 5 hours later, I can't take that. Are you kidding me? Does everybody understand? Okay, you're only supposed to get so much time on it. And I'm really sorry that I can't take your word on such things, but all right. If you still have questions about exactly how that's going to work, let me know.
So the 1.4 is not on the quiz?
There you go. That's right.
Mm-hmm.
You still have to do it for homework, but it's really
Okay.
not crucial, which is one reason why I didn't really lecture on it, but you should be able to. I just want you to know those words exist. And I was telling somebody earlier, if we were doing a class like an advanced stats course, like a research methods course, where you actually have to design an experiment, we would get so much deeper into those like blinding and confounding variables and placebo stuff. That's what section 1.4 is about. So you don't have to memorize those words. You just have to be able to use them in the homework. It's not a huge part of this class. Okay. Everybody good? Any other questions about the quiz? How it's going to work?
There is something like key term thing on the quiz. Key term? Do we need to write from key terms of like data? Yeah, data and population something.
There's going to be questions about population and sample and stuff. Yes. I never ask you a definition. I never say define population ever. I'll never ask.
So what is a population?
Yeah, I won't ask you that. I'll give you a situation and say, what is the population in this situation? Just like the problem we've done. Yes.
Okay.
I like it. Anything else about the quiz, guys? While we're talking about that, no?
It's like the homework. It like quiz is like same as like homework.
In terms of what?
So it's like quiz is like a homework you gave us, like 1.5, one and one, like this.
A quiz is not like homework. A quiz is like homework in the way you submit it, but a quiz is worth a little more, especially all the quizzes together, right?
I think she means that are the questions on the quiz going to be structured like the quick questions on the homework?
Yeah, like a homework.
Is that what you mean?
Yeah.
All right. Hopefully I constructed my questions better than the book does sometimes, right? They have a little trouble sometimes with wording a question so it makes sense. So hopefully I've worded it better, but you won't see problems that are very different from what you've been asked to do. That would be kind of mean, if that's what you're asking, right? All right. I don't make them exactly like the book, but I don't make them very different because that would be mean. All right. I think okay. Anything else, guys? Anything else about the quiz? Somebody else asked me, so once we open the quiz, can we copy questions and answers? Yes, of course. You don't have to print the quiz out because I know not everybody has a printer. I have a printer that likes to work like every other day, so I understand. Sometimes I get lucky. I'm like, oh, good, it's printing now. Oh my God. All right. I don't get a new one because I really don't need a printer. I really don't. Okay. If you think of other questions, you can ask me at the end of class. So nothing from homework? No questions from any homework? Okay, all right. We'll do this. We'll get back into this. What do you call it, Jeff? You can do it, buddy. Use your words. The handout that was up here. Let me remind you guys where this thing is. I think we worked on the first side. We didn't finish this back side, right? Where is it, Jeff? Here. Here. Histogram, stem plot practice. Remember this thing? Do. So if you were not here last time, it's up on the video, up on YouTube. We did the whole first side. We talked about shampooing people's hair, and then we have not done this backside yet, but I think you guys at least started this. So we're going to do this together. I'm going to open this in a better way. Hold on. So that's where to go find it. Let me open this in a better way. I'm going to see how long I can keep my moon on behind me. It's my moon. All right, where'd it go? Here it is. All right, let me move you guys. Move this over here. Move this over here. Hold on, guys. Oh my God. Oh yeah, that's right. I already have it open. There you go. That works. So here.
This was in modules, wasn't it?
Yes, it's in modules. And it's in unit 2. Let me see.
Oh, I got it.
I like it. All right, cool. So we did this last time, right? So let's do this real quick. I believe we put this in our calculators. I showed you how to put this in the calculator, right? So we could sort it. Is that correct? I believe that's true.
Yes.
Okay, thank you. So let's do this work. How do I find, so I've got the work down here. I tell you to use 5 classes. I'm not always going to tell you. Oh no, everybody bear with me. Hold on.
Bluetooth mode. Bluetooth connected.
Somebody say something to me.
Hello.
Thank you. Okay. I don't trust my printer anymore, unfortunately. I'm a printer, my speaker. There we go, Jeff. Let me see. Oh, now I can't do anything. All right. So, whoa. I am not normally going to tell you how many classes to use. Can somebody remind me what's the least classes we want to use in general?
5.
5. I love it. And the most is 10. And I'm never going to give you a sample large enough to use 10. So this one, I tell you to use 5. If you still have this data in your calculator and you got it sorted, you might be able to answer this question quicker. But what's the highest data point in this data?
79.
Yeah, 79. And what's the lowest?
61.
61. And then I want to divide by 5. This is going to tell me, and we went over the physical meaning behind this formula. It makes sense. It makes physical sense why we do this, to see how wide each rectangle is going to be. So when you do this, you get 18 divided by 5, which is
3.6.
3.6. So I round that up to 4. I like it. Sweet. Any questions out there? All right. So the lowest data point was 61. So let me start at 61. The class width is 4. So the next class should start at 65, which means this one would go to 64. Now remember, if you want to, you could use this, 61 less than or equal to x less than 65. 65 less than or equal to x less than 69. Then you can see the class width. That's your choice to make. Okay, I like it. And if I just keep adding 4, add 4, add 4, add 4, and then add 4, add 4, add 4, add 4. All right. So now every data point should have a place to go. Let me see if I still have this data in my calculator. Did I put it in my calculator? I don't know. So much happens every day. Monday feels like a month ago. Let's see. So last time, I'm pretty sure I did this with you guys. Remember this? Wait, you can't see what I'm talking about. We did this together. We put the data into the list and then we sorted the list, right? So you might still have this in your calculator. I don't know. So let's come back here. So now all I got to do is count how often data shows up in each of these categories. So how often does something show up between 61 and 64? Only. Does anyone still have that list in their calculator? How many times does a data point show up between 61 and 64?
How do you find that on your calculator?
All right, so let me show you. It's kind of that the question you just asked isn't really correct in a sense. There's the data. So how often does something show up between 61 and 64? Once, twice, right? Don't those two show up between 61 and 64?
Oh, I see what you're saying. Yeah.
Yeah. And then what was it? 65 to 68 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there any more? I don't know. 10, 11, 11. It looks like 11. Is that right? You guys with me out there? Anybody not with me? So 61 to 64 is 1, 2. 65 to 68 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11. Oh shit. What am I sharing with you right now? Can you see my calculator?
Yes.
Thank God. Okay. I'm curious about some of my colleagues because they're not very good with technology. I like to think I am. And I'm always wondering, what are their classes like? Anyway, so there's 2 here. There was 11 here. Now help me out. Keep going. How many showed up between 69 and 72? Oh shit, what did I just do? I just did the wrong thing. Yeah, Jeff, you're fantastic with technology. All right, let me see here. All right, there we go. Let me catch up to you. So yeah, 69 to 72 looks to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I see 11, 12, 13. Is it 13? 1, 2, 3.
I got 13.
13, yeah. Do you see that? 13? All right. Please let me know right now if you have no idea where these numbers are coming from, because you're going to need to get them yourself. Okay, I'm not hearing anybody. What about 73 to 76?
7.
7, I like it. And then 77 to 80.
2.
Yes, 2 79s. I like it. Now, what can I do to kind of check to make sure this looks to be on the right track? How many data points were there? 35. So all of these should add up to be what? 35. I like it. Well, let me turn my speakers up a little bit. Why are you giving me so much trouble, speakers? Oh, I love you so much. Hold on, everybody. Ooh. Okay, let's see. Oh. All right, that should work. Okay, we'll find out. So what about, I'm sorry, do they add up to 35? 9, 20. Yes, I like it. Let me know the minute I'm not making any sense. All right. Relative frequency, that's just another name for percentage. So how do I see what percentage of the data is in this first class?
2 out of 35.
Yes. And what is that? 2 divided by 35. What percentage is that?
0.057.
Sounds about right. Yeah, so we'll say 5.7%. And then you just keep going. 11 divided by 35. Ooh, 31.4%. 13 divided by 35 will be 37.1. Is that what that is? Just to make it up. Okay. Somebody's rounding less than me, but that's all right. Or more than me, I guess I should say. And then 7 divided by 35, that's an easy one. 20%. 2 divided by 35 is also easy because we already did it. Yay. Now, if I add those percentages up, what should they be?
100 or 101.
Or 99? So they should be close to 100. I like it. And if I do add them up, what do I get? Let's see. Oh, crappity doo-dah. I get 74.2. I get 94. I get 99.9. Does anyone else get that? I did that a little quickly, but sorry. Yes, okay. What goes here for cumulative frequency? What goes in the first spot for cumulative frequency?
5.7.
5.7. I like it. And then I accumulate this much. So now I'm up to
7.1.
37.1. I like it. And then I accumulate another 37.1. So now I'm up to
74.2.
kick ass. And then I accumulate another 20. And then I accumulate another 5.7. And there's that 99.9% we knew already. I like it. I like it. Not too bad, right? This is not too bad. Or is it just me? All right. I'm going to shrink this down a little bit so I can hopefully show. I can't do it. All right. It's too small. Yeah, you guys can still see that. So now, if you do it this way, what has to show up on the scale down here? What's got to be here? Down here.
Oh,
Oh, what? What?
60.5.
Good. 60.5. And then I could just go by 4 because I know that the class width is 4.
We can't see your screen.
What happened?
It's too low. We can't see.
All right. Is that better?
Yes.
I was trying to show all this too, but yeah, I can come down here. So just keep adding 4 now. Okay, there we go. Now, if you do it the inequality way, then you could just do 61, 65, 69, blah, 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 right? So don't mix and match. If you do it one way, you got to do it one way all the way through. I'm making a relative frequency histogram. So which numbers do I need to use? Do we use 2, 11, 13, 7, 2?
The percentage, the 5.
Yeah, I've got to use, yeah, I like it. So I could ask you to create a frequency histogram and then you would use these numbers, but no, we got to use these numbers. And the highest I've got to go is 37. So maybe I'll go up to 40. Please, dear God, don't go up to 100. Don't make this 100 because then you're going to smush your picture. It's going to be smushed. I'm going to go up to 40. So maybe I can use a scale let's see, can I squeeze 5% in 5, 10, 15, 20? Yeah, this will work. 25, 30, 35, 40. There we go. I could have even done less than that. I like it. You guys all with me? As I'm doing this, just think to yourself, could I do this by myself? What am I going to label? I'm not always going to remind you about this, but you will lose points if you don't label things. What am I labeling the you can do it, Jeff, the vertical axis here?
Relative frequency.
Yeah. Real freak. And what am I labeling this axis, the horizontal axis? What do these represent?
Father's height.
I like it. Father's heights in inches. And now I can just draw my, here's the easiest part of this problem is just drawing my rectangles, right? So the first rectangle is going to go up to 6 almost. So just a little over 5. The next rectangle goes up to 31. So it'll be a little over 30. And then it goes up to 37. Oh boy, we get a little wobbly. And then 20. Oh crap. And then 6 again. Am I wearing my shirt? I am wearing my shirt. Would you say that that looks roughly bell-shaped, roughly normal? Like
Yes.
really roughly, right? Not perfect, and no means perfect, but it does look, if I overlay this, ooh, if I overlay, there we go. It looks roughly normal. This is a little bit out of sorts, right? But it's roughly normal, which I expect. This is actual data, by the way. Oh, I keep forgetting. Did I send out an email about the surveys? If you haven't filled the surveys out, can you please do that? Thank you. So this is actual data, and I expect heights to be normally distributed. I expect most people to be in the middle, and then a few really short and a few really tall. So it will almost always be a normal curve when I'm talking about heights. Okay, maybe. Do you have to do this thing in green? No, that was just me adding stuff on. That's not a part of the answer. What's up? Sorry. Does somebody have a question? Anybody? You guys good? Okay. That's it. That's enough of that. So we are going to get into our next section. So we've done section 2.1 and 2.2, believe it or not. We're going to get into 2.3, 2.4, and 2.5 today, is my hope. Let's see if I'm able to do that. Has everybody got what they want from this? More than you ever wanted? Okay, I
Yeah,
understand.
for the most part.
Huh? Sorry?
No, just agreed.
Okay, thank you. So I'm going to stop sharing this. Kabam. All right, so now I'm going to go up on the, oh, I got to turn my moon off. That's no moon. Yeah, it is. Don't worry, it's a moon. All right, so choose virtual background.
I'm right. Crap. It's not.
Is everybody okay? Let me mute everybody. There we go. All right. Get up here. All right. So has anybody ever heard of percentiles before?
Yes,
Yes. In what context?
the doctor.
Oh, good. Perfect. Do you have kids? Or was
Uh,
this?
No, it was them telling me I'm short.
Oh, okay. Sorry. So that's pretty much exactly what I was thinking. If you have children, if anybody has children, you do know about the height and weight chart. and they tell you where your kid is. So there's like it looks something like this. And a friend of mine, their kid was here for height and roughly the same for weight. And they had named him Max, which I thought was perfect. He's a Max little kid. So all that means is if you're in so for example, if a kid is in the 30th percentile for height, what does that mean?
They're 30% taller than.
No, careful. That would mean that they are taller than 30% of all other kids at that age.
Does it mean they're among like the 30% of roughly all children?
Yes, of all kids at their age. Let me stop for a minute. That's what a percentile always means. The 30th percentile means 30% are below this score, whatever it is. So 30th percentile in height means that 30% of the other kids are shorter, or this kid is taller than 30% of the other kids. All right, you with me? Okay. So I'm going to erase this. This is how you interpret every percentile. They only mean the one thing. All right, here we go. I'm going to erase this. So what if I score in the 95th percentile on a test? Am I happy?
Yeah.
Yes. Does that mean that I made an A?
Yeah. Not necessarily.
Not necessarily. Exactly.
Because it's referencing the people that took the test and not
You did
score.
You did 95% better than.
No, careful the way you say it. You did better than 95% of the other people that took that test. You all could have failed, correct?
You failed.
But you got almost the highest failing grade. So you could have your score could have been a 42. You with me? It just means that most everybody else, 95% of everybody else scored below a 42. That's what it means. Okay, I think hopefully everybody's with me. That doesn't mean the same thing as making a 95 on a test, right? A 95 on a test, you could actually be in a very low percentile if everybody made a really high grade, right? Okay, maybe. So in this case, I'm happy in a sense, but it doesn't mean I passed, to be honest, but it means I did relatively well compared to everybody else. All right, maybe. What if I score, what if you are in the 10th percentile? My grammar sucks here, but oh well. For golf scores. Are you happy or sad? This depends on you knowing how golf works a little bit. Does everybody know how golf works? A lower score better or worse?
Worse.
Better.
No, better. So in golf, the score represents how many times you had to take a swing at the ball, and the fewer times means the better. So if you're in the 10th percentile for golf scores, you're feeling really damn good. Only 10% of other people are better than you at that particular game, whatever the game we're playing.
So it's just backwards.
Yeah, golf. So this is what I want you to understand. This is the point I'm trying to make. High percentile doesn't mean good. It depends on the situation, right? But high percentile always means your score is above a large percentage of people, right? So a percentile always means the same thing, the interpretation depends on the situation. Okay, good. Because there's going to be quite a few homework questions where you have to, number one, interpret exactly what it means. And number two, tell me if that person should be happy or sad. Okay. So how do I calculate a percentage, a percentile? So I'm going to make up 10 numbers real quick here. Let's see. You can do it, Jeff. What is that? 1, 2, 3, 4, 5, 6, 7, 8. Damn it. 9, 10. All right. I always forget. I don't have a very big whiteboard. Okay.
Would you put it in classes?
No, we're not going to do a histogram. But I think I know what you mean. But we're going to do what we'd have to do even if it was a huge set of data. So I want to show you the most general way to do percentiles. I think I know what you mean, though. We're not going to do it that way. Can somebody tell me what their guess is for the 80th percentile? Think about what a percentile means. What number do you think represents the 80th percentile? It's kind of bugging me.
36.
All right, so I got a vote for 36.
39.
I got a vote for 39. So why'd you say 36?
Because it's a bigger number than 80% of the numbers on the board.
And how did you figure out the 80% thing?
I didn't figure it out. I thought we were just guessing.
Oh, I see what you mean. So you totally guessed. I gotcha. So I understand. This is good. No, you're fine. That's beautiful. I love it. Let me come back. I don't want you. You did great. You're like 80th percentile. It's got to be over there somewhere, right? Because 50th percentile would be in the middle, right? I love it. That's beautiful. What about 39? Why did you say that? Was it the same reasoning?
I put, I just said maybe each point is 10. And
Of course they would.
Spot.
Yeah, so how many numbers are below 39? 1, 2, 3, 4, 5, 6, 7. Well, there's 7. All right, or did I count? 1, 2, 3, 4, 5, 6, 7.
39.
So that would could be more like the 70th percentile.
Oh, because it's before. Got it.
All right, now let me stop for a minute. All right, I really want you guys with me. 80th percentile is supposed to be the number that has 80% of the data below it, which means it has how much above it?
20.
20%.
20%. So 40 is not a bad guess because it's got 1, 2, 3, 4, 5, 6, 7, 8 out of 10. It's got 80% below it. But how much does it have above it?
10.
10%. Shit. So then this has 20% above it, but only 70% below it. Now stay with me. So the answer is going to be in the middle of those two. The number in the middle of those two has 8 below it and 2 above it, correct? Okay. So what's in the middle of 39 and 40?
39.5.
Exactly. And here's the symbol we use for 80th percentile. It looks like this. I like it. So this is not a good enough. I want to develop a more rigid set of rules to find any percentile. And this is still a little bit hand wavy. So here's what happens. 80%. So if I want to find P80, I do two things. Tell me if this makes sense. To find the 80th percentile, I go 80% of the way into the list. 80% of what? Well, how big was the list? 10. So will this number always be 10?
No.
No, good. All right, good. That seems kind of silly, but I want to point that out because I always have people, somebody puts a 10 there for everything. It depends on how big your list is, right? I want to go 80% of the way into the list. And what is 80% of 10?
8.
8. Now get ready. Here we go. Oh shit. When I do this first step, if the answer I get is a whole number, I round that number with the next. So this, I got an 8, so I'm going to round the 8th and the 9th together, which is exactly what we did, right? Okay. Anybody not with me on this so far? All right. What else could happen, Jeff? Okay, so what if I ask you to find, what do you got, Jeff? Let's do P13. What would my first step be?
13% of 10.
Yes, 13% of the list size. Can you guys see that all right? I guess so. And that would be 1.3. Now stay with me. There's only two things to memorize here. Either you get a whole number, so that means you round that 8th number with the 9th number, bam, or you get anything else. If you get anything that's not a whole number, you round up and you take that number and you're done. So I'd round this up to 2. So then the answer is the second number. Done. That's it. That's how you do any percentile. All right, maybe. How you guys feeling out there? That's not that terrible, is it? All right, so here we go. What's up? Sorry. Everybody all right? All right. I'm gonna race. You guys ready?
Wait, why do you get the second number? Or pull the second number?
So if you do this first step and you get a whole number, you round that one with the next one. So I round the 8th with the 9th. If you get anything else, you round up and you take that number. So we got 1.3. We round up, we take the second number.
Okay.
So no matter
Where'd the 11 come from?
Wait. Somebody else. Sorry.
Huh?
No matter
like what decimal, like even if it's like 1.1, we still round it up to the next
Total.
number after.
Yep. You got it.
So where'd the 11 come from?
So the answer is the second number. What's the second number?
11.
There you go.
Wait a second.
What must be true about your data then that I made happen?
It has to be based off the list.
I'm not sure if you mean it has to be in.
Numerical order.
Sorry?
Numerical order.
There you go. It's got to be in order. Right? If it's not in order, you can make any percentile be anything you want it to be. Okay, since they are ascending and there are 10 numbers and 9th numbers higher than 80% of them. Oh, that was from before.
So if let's just say the number, instead of it was like 13 or something, and the decimal came out to 2.6, we would round up to 3. Would that make the other percentile like the third number, so it would be 15?
Yeah, if we did this work and we got 2.6, round up to 3, the third one would be the answer.
Got it.
Yeah, the third number, 15 would be the answer. Yeah. Now, I do want to address something. Is this a very large set of data?
No.
Can you guys tell me real quick what the 12th percentile? Can somebody do that without any work? What would the 12th percentile be?
2.
the second number, it would be 11, right?
So it'll be the
Everybody
first
with me?
one, too.
That tells me which number is the answer. Go get the answer. So wouldn't P12 would be 12%, it'd be 1.2, round up to 2, it'd still be 11.
Oh.
So it makes complete sense. If I only have so many numbers, they're going to have to repeat. There's not going to be a number for P11 and a number for P12 because I've only got 10 numbers. Okay, maybe.
Oh, so you just start over.
Start over. What do you mean?
Like you count past the whole list and then you just count again. And that's how you got to 11?
No, I don't understand. This is 100%, so why would I go past that?
No,
This work. Sorry.
You start counting the list over again. Is that what you're saying? I'm not sure I follow because I wasn't sure how 11 is in the third percentile or what.
Third, so 13th.
13th.
Right? Yeah. So 11 is in the 13th percentile because that's what we got when we did the work, right? We got.
Tile
Yeah.
80.
I think he's thinking if if the answer in the first part was 11, do you count 10 and then you go back, or you just say 43? Like,
Oh.
this is 1.3.
All right, now listen. Wait. I love you guys so much. Is that what you meant? If so,
that's what I meant.
Listen.
Thank you.
What is the highest percentile we can do? Highest percentile.
100.
100.
Percentile. 100th, right? What's 100% of 10? 10. You ain't never gonna get above 10 because that's all you got. I love you guys. So if you do this work and you have 10 numbers and you get on this step, you get 13, you did something wrong. So, okay, now that question makes sense, but I hope how you see that it doesn't make sense. Is that all right? You'll never get more than the 10th spot. Okay.
So at that point, you could just make an estimated guess.
Say again, sorry?
So at that point, you could just do an estimated guess. You don't gotta do any of that work. You could just, let's say what's the percentile of 100% out of these 10 numbers, the answer is going to be the last number.
Yes, you're done. Yeah. Okay. That's why we really don't talk about the 100th percentile. It's not really a thing we talk. We just call that the maximum data point.
Okay.
Right. Okay. No. Go ahead.
I had a question. So the percentile, the 80. So we got the 8 number, like 10, 80 divided 10 equal to 8, and
Yeah.
that one. Yeah. So we
So
can
get a whole number on this step. If you get a whole number on this step, you round the 8th and the 9th. So if I do the first work and I get 6, I'm going to round the 6th number with the 7th number. So if I get a whole number on this first step, I take it and I average it with the next one. If I get anything else, I round it up.
I'll
and take
round it up.
Yes.
Okay. Got it.
It's almost nice to get a decimal because then you round it up and you're done. You just take the number, you're done. This one, oh shit, I got to do some work.
So exactly the 8. Just so
If I get
it's not
exactly
round
a
up.
whole number, I average that one with the next one.
Okay, got it.
I like it. All right. I'm going to erase this. We're going to do another example. And we're going to do more.
Someone had a question in the chat.
Oh, shit. Whenever I'm up on the board, I'm sorry. I might miss. Why are we allowed to answer with a number? Oh! All right. So watch this. Let me see. Watch this. You ready? 1, 2, 6, 10. What is the number that is right in the middle of all the data points?
4.
4. Is that one of my data points? No. Right? Wouldn't 4 be right in the middle of all the data points? Isn't that what percentile is it that I'm finding? If I find the one that's right in the middle, you could do it.
50%.
50th percentile. So if I do 50% of 4, I get 2. What does that mean? Average the second and third. And that's exactly what you did because it just freaking made sense, right? You did it without even doing the work because it was a small set of data and you can just see the answer. I like it. What's the average of these? I'm getting a little ahead of myself, but you guys should know how to average these, right? What's the average? Anybody know how to?
5.
Huh? So it'll be 1 plus 2 plus 6 is 9 plus 10 is 19 divided by 4.
4.7.
4.75.
Yeah. Is that one of the data points? No. All right. So these kind of numbers have to be within our data set, but they don't actually have to be one of the data points. Okay. We know that already with averages. You're not going to find a family that's got 2.5 kids. Thankfully, I don't want to go to the house. That little half kid comes down. I'm like, ah, what is that? It's like the island of Dr. Moreau. All right. I don't know if anybody gets that reference. So I'm going to make a longer list here, a little bit longer, a new list. What's that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Dang it, Jeff. 10, 11. I always have to have one hanging out. That's fine. 12. Okay. So let's do this. Let's do 3 things. I want to figure out, well, tell me these 2 things. What's the lowest data point? Ooh, that's 40. I'm going to answer that question myself. Then I want you to figure out P25. But what's another name for the 25th percentile? If I go 25% of the way through of a football game, maybe, what am I at the end of?
First quarter.
The quarter.
So another name for P25 is Q1. How do I find Q1? What do I do? P25. What do I do? I'm sorry. You guys,
You go to the
25% over, no,
yeah, 25% of
10.
there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay, that.
Right? I'm really making that clear that that number depends on how big the list is. Please let that make all the sense in the world. If I want to find about where the 25th percentile, the number that has 25% below it, I'm going to go 25% of the way in. And can somebody tell me what is 25% of 12?
3.
3.
And why did I make it 12? That's too bad, Jeff. And what do I do when I get a 3?
Third number.
No.
Average the last 2 together.
Yes. Average. What do you mean last 2? Average the
Third and fourth.
third and fourth. So let's see what we get. The third and fourth. So if I average 43 and 49, what do I get?
$46.
46. So that's what Q1 is. Now you guys do, what would I call P50? I'm going to call that Q2.
2.
Holy shit. Go ahead and do Q2.
50% of 12.
Hold on. Wait for everybody.
It's 24.
5, 6, 7.
Yeah, so half of 12 is 6. So I'm going to average the 6th and 7th. So 1, 2, 3, 4, 5, 6, 7. I want to average those two. And what do I get when I average those two? You actually don't even need to do the work, right? What is that? What's in between those?
7.5.
67.5. I like it. Okay. And I bet you can't guess what am I going to do next. Yes, you can. I'm gonna copy down what we got so far. The lowest is 40. Q1 we got 46. In Q2 we got 67.5. So I'm gonna erase this stuff. Everybody ready for that? I'm gonna erase all this. Here it goes. It's going away. All right. All right. So now do what you should have been expecting. What's Q3? Third quartile. So it's also known as P75, right? Those mean the same thing.
So 75% of 12.
Good. 75% of 12.
Nine.
And what does that mean?
Numbers between the
Average of the 9th and 10th.
I like it. Average the 9th and 10th. Let's see. 12, 11, 10, 9. So I want to average these.
$76.
76, 11. Cool. So now let's see what we got. We got the lowest is 40. Q1, 46. Q2, 67.5. Q3, 76. And then the highest is 85. Okay. This little set of numbers is called such a creative name. It's called the 5-number summary. That's what these are right here. That's the 5-number summary. It's kind of like the beginning of the game, the first quarter, second quarter, third quarter, end of the game, right? And what we can do with this is we can make a visualization of this. All right, I'm going to erase this. You guys ready? All right, let's see what happens if I start doing it. All right. So here's what I can do. Here's what I can do. And this is where some of us need some help with scale. It's going to drive me a little insane. Whenever you make a graph, your scale must be consistent, meaning every step must be the same amount. So I want to make a scale. It kind of makes sense. I'm going to start at 40 here, and I want to be able to go up and include 85. Okay, that seems to be, let's see if we go by fives. 45, 50, 55, 60, 65, 70, 75, 80, 85. There we go. Isn't that beautiful? There you go. All right, everybody do that. But we're going to do something a little different than you're used to. We are going to put a line so over each one of these. So over 40, I'm going to put a line. Over 46, I'm going to put a line. Over 67.5, I'm going to put a line. Over 76, guess what? And over 85, another one. Okay. Right? And then we do this. Tell me if this starts to look familiar, if you've seen this. See the middle 3 lines? Draw a box around them like that. So that's the box. And then here come the whiskers. So the book calls this a box plot. The actual name is box and whisker plot. Has anybody ever seen one of these out in the wild somewhere? Some of you guys?
Yes.
Okay.
Yeah, I seen it in my first math class. I don't remember what it's called.
That's not really out in the wild. right? That's in the math zoo. But you see this sometimes in articles or on the internets, or really you see this a lot when you research colleges and they talk about SATs and GPAs. They kind of show you percentile stuff, some box plots. Can somebody tell me what's in the box? Can somebody tell me what percentage of the data is in this box? I love this question. Let me help you out a little bit. What was this line? Remember? This is low, Q1, Q2, that's Q3, right? And what's this line?
Q1.
Q1. What percentage is below Q3? What's Q3 all about?
75%.
75.
75%. And what percentage is below Q1?
25.
25%. So what percentage is in the middle?
50%.
50.
50. So this box is always the middle 50%. It's like the heartland, right? Maybe. All right. That's really all there is to percentiles and box and whisker plots. They're pretty straightforward. Let me show you this. I might as well show you this. If you have your calculator, get them ready.
What did you say the book calls that type of plot?
Box plot. I think it's section 2.4. They call it box plot. The actual name is box and whisker plot. All right, so if you have your calculator handy, let me show you something kind of cool. So I like to show you ways on the calculator to check your work. This is not counting as your work though, if you do this in the calculator. So let me show you. Can you put this data set in the calculator? Do you remember how to get there? I'm already there, but oh well. How do I get to my lists to put data in? Do you guys remember?
Stat?
Oh shit. Sorry? Oh yeah, stat. That's right. So you hit stat. That's always a really good button for this class. And then edit. And then I can put my data in. So I'm going to clear this data out. I'm going to go up to list 1 and hit clear, enter. Because now I can put this data in. Is everybody with me that wants to play along? All right. And while I'm thinking about it, I put up in the announcements a flyer for calculator workshops that they're doing. There was one today and there's one the next 3 days, I think. I can't remember. So there's a flyer in the announcements on our Canvas shell about calculator workshops in case you've never used this calculator before. I'm still going to show you how to do things, but there's a workshop too if you want to get some more stuff. All right, so let's take a minute and put this data in there. I don't want to do it that way. Let's see. Okay. It's always nice when you make sure the last one is in the right spot. It's in the 12th spot, which is good. Now, watch what I can do. I'm showing you this a little bit earlier than I normally do, but oh well. So once you get them all in there, all your data points, if you hit stat, calc, I can calculate one variable statistics. So I'm going to calculate statistics about the one variable that I put in. So my list is list 1. There's no frequency list. calculate, and then look at the last 5 things I get. I'm going to talk about the other stuff later, but look at the last 5 things I get. What is this?
The 5-number summary.
5-number summary. That's right. So that's a nice, beautiful way to check your work once your work is done. All right. Do not, if you've taken stats before and your last stats teacher lets you just get the answers from the calculator, I don't give the first shit. You don't have that person anymore. You got to show me your work, but I do let you check it. Why not? I like it. So don't write down, this is my work, Jeff. These are the buttons I pushed. No. Try again. Okay. All right. So what I want to do, let me see. Have I made it? Is that? Yes, that was it. Good. We can do this now. Let me show you. If you look in our Canvas shell, let me show you. Go to modules. Let me become a student so it looks more like what you can see. Come here. There we go. So good. Now it should look like this for you in the modules. If you go down to unit, oh, I gotta unblock it. Hold on. Let me make it so you can access it. That might make it work better. All right, sorry. Hold on. Jesus. Bam. Okay, that's all I had to do. Let's try this again. So if you go to Canvas, go to modules, come down to unit 2. Do you see the percentiles and box plot practice? All right. Oh, please, dear God. Don't do part A. Let's not make a whole nother histogram. We already did that today. You don't have to do that. But I do highly recommend that you put this in the calculator and sort it, right? That'll make it much easier to do the percentile stuff. Can you guys get to this worksheet on Canvas?
What's it called?
Let me show you again. So it's in unit 2 for chapter 2. We already did the histogram one, so it's this one, percentiles, box plot.
I only have the histogram one showing.
Well, you might have to refresh. I just made this one active. So hit refresh, it should show up. Is anybody else able to get there?
Yeah, it's there.
Okay. So pull that bad boy up and give it a try. Don't worry about part A. I'm going to let you not do part A. Please don't do part A. Do part B, C, D, and E. Don't worry about part A. Okay. There we go. That's better. Is anybody not able to get this themselves? Are you all able to get into Canvas right now? Let me see if I do that, if anybody screams.
Unfortunately, I don't have the calculator, so I got to do everything by hand.
Well, that sucks. And Anthony, what do you mean you can't print it? You don't have to print it, really. You don't have to. No, you could just do the work on another sheet of paper. Thankfully, this is not a huge set of data. You could probably order it by yourself. You don't need the calculator to sort it for you, right? You can sort that.
Yeah.
Okay. Huh, where is it? Mm. Let me see. Percent, oh, 160. Okay, okay, I see. There it is. Lord, sorry. Let's take a look here. I know you're probably not quite done, but let me see these first couple. So when you're doing P17, what is 17% of 20? You're chatting at me. Hold on. Yeah, 3.4. So
3.4.
What does that mean?
Round it up to 4.
Good.
So it'll be 65, the fourth number.
I like it. The fourth number is 65. Kick ass. Over here, 72% of 20?
14.4
Yeah. And again, you round up to
15.
15. I like it. So 20, 19, 18, 17, 16, 15.
So 87.
I like it. Is everybody with us? You guys okay out there? All right. So it's kind of nicer when you get a decimal. It's like you round up and you're done, right? Now, this is a little bit weird. This is not the best way to ask this question, but what theoretically does this answer mean?
The person scored 65% better than like most of the class. No,
Not 65% better. What's the percentage?
3.4.
No. That's part of the work. What's the percentage? 17. So if you made a 65, you scored higher than 17%. If you made, become a thing. 65, you scored higher than 17% of the other people.
Would it be different if I were to say 17% scored 65 or higher?
Yeah, because it should be, it's not, it should be less than 65. You could say 83% scored 65 or higher. Do you see what I mean?
Could I say 17% scored 65 or lower? Or is that
Sort of.
okay?
But it should be 17% scored lower than 65.
Okay.
Yeah. And again, when you have such a small set of data, you're going to have a lot of repeats. It's not exactly 17% because it's just a small set of data. All right, maybe. And now to do the 5-number summary, you do have the shortcut to check your work, but you got to do your work. So the lowest data point, of course, was 47. How do I get Q1? That's also known as P25. So this is not too bad, right? 25% of 20. What do you get for that?
The fifth number.
Good.
So take the average of the fifth and the sixth.
Kick ass. So the 5th and 6th would be, let's see, 1, 2, 3, 4, 5, 6. So that's awesome. They're both 68, so it's 68. That's the best thing. When they're both the same number, the average is easy. Q2, P50, you take half of 20. You get 10. You can check. So that's the 10th and the 11th. Is this cool? I mean, you just keep doing the same thing. There's only 2 things that could happen with a percentile. either you average 2 or you round up and take it. So I get 10. I got to average the 10th and 11th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I got to average 73 and 80. What do you guys get when you average 73 and 80?
76.5.
The gas. And then here's a shortcut for Q3. I didn't show you this before. This is kind of nice. Do you see how this was 5th and 6th from this side? So Q3 is going to be 5th and 6th from this side. 1, 2, 3, 4, 5, 6. So 87 and 88. So that's a bit of a shortcut there. I have no idea if you guys understand. So if Q1 is 25% of the way in and Q3 is 75% of the way in, I can use this just starting at this side. If that doesn't make sense, then just do 75% of 20 and do the whole thing. Did anyone else get this answer?
Yeah.
Yay. And then the highest one was 99, right? And then we can do our box plot. I want to go from about, let's say 45 up to 100. Let's do 10s, just be careful. 55, 65, 75, 85, 95. I like it. And then 105, there you go. So you can use whatever scale you want to, make sure it's consistent. And then you just draw your lines. 47, 68, 76.5, 87.5, and 99. And then you make your little whiskers, and then you're done. Okay. That's not too bad, right? Is it evil? It's not too evil. All right. If I remember, I could post the answer key here to Canvas. Let me see what time we got. I just got a little bit more I want to do with you guys. We're going to plow through a bit and we'll leave a little early. All right. We sort of already kind of previewed something else I want to do. So I just want to talk about the 3 ways to figure out where the center of the data is. And that'll be the last thing we talk about today. All right, so has everybody got what they need from this? You guys good with this? Can I stop sharing? Let's see if anybody yells at me if I stop sharing. No, okay. So last thing we're gonna do. And most of what we're about to do should be familiar to most of you. Come on, get over there. So when I say where's the center of the data, there are several ways to identify that. The most common way is what we call the average. But the word average means more than one thing in statistics. So when we say the word average in everyday life, we actually mean the word mean. So the mean is just another name for what we call the average. And we know how to find this. So this will be our first little statistics equation. It's an equation we don't even need, but I want to introduce it just to show you some of the symbols we're going to use. I don't know if you guys remember, there's not a lot of algebra in this class. What gets people down are the Greek letters, right? Because we use a lot of Greek letters. And the formulas and the concepts. Okay, now, so. Can somebody tell me in English how to figure out the average of a set of data? What would you do?
Add everything up and then divide that number by the amount of things you added up.
Add them all up, divided by the number of things. I like it. Now, math people don't like to write all this many words. So here's what we use. Okay. Instead of atom, we use the symbol. What's the official word for addition? But it's a little tiny word.
Sum.
Sum. So we use the Greek letter S. This is the letter sigma. It's actually the capital letter sigma. That means sum up these. So I need something after it, because this right now it means sum up all of the. So what do I use for all the numbers? Well, what do we use in algebra for a list of a bunch of numbers? X, right? Good old variable. So add up all the data points, and then what letter am I going to use for the number of things?
N.
That's right. N. I love it. Okay. That is the equation for the mean, what we call the average. So let me ask you this. Oh, and the symbol for this, the symbol for mean depends on if it's a population mean. The population mean would have the symbol mu. So that would be the population mean. And the sample mean, by the way, real quick, I have that whole list of all the Greek letters up on Canvas, right? So you can look at that if you want to. You don't have to memorize it. Remember, this little dude is like a U with an extra leg. It's not really an M. And how do you say this? It's mu, right? And so a population mean is mu, and a sample mean is X bar. That's exactly how you say it, X bar. So for a couple things, population has Greek letters, sample has our letters. For a couple things. Okay, how are we doing so far? Notice they're the same freaking formula because they represent the same idea. So let me ask you this. What if these are my data points? Okay. What is this then? What is the sum of X?
Would it be all the numbers that you added up?
Yeah, that's it.
Times 4 or 5 or 7 or
Just sum of X. What's the sum of all the X's? 25. Is everybody with me, right? What would I have to do? Why was that easy? Because I gave you what the X's were so you can add them up. So what if I wanted to know what this was? Be very careful. This does not mean square 25. That is not what that says. It says sum up all of the X squares. Do we have the X squares?
No, you have to input each number.
Good. You have to make it. So if we can make a list of X squares, I can add them up, right? So this would be 16, 25, 49, 81. Is everybody with me? So many of our formulas are going to have this symbol followed by something. So I say to myself, I cover that up and say, oh, I need a bunch of those. So then I can add them up. So what do you get when you add these up?
171.
Is it 171? So you said? Yeah, 171. I like it. Okay, that's not that bad, right? It's really not that bad. So it's going to become something big in section 2.7. And then in a few other places this semester. Okay, I like it. So that is, so if I wanted to know the mean of this, of course, let's say this is it doesn't matter. But if I said this is a population, it's a very tiny population, the mean would be mu. And of course, it would just be 25 divided by 4, right? Nothing major there, right? The fact that there's a formula that exists does not change how you do it. It's just the symbols we use to represent the idea. Okay. That's all math is I know Greek is a different language, but math itself is just a foreign language. Here's English, here's math. All right. I'm going to erase all this. You ready? Who's heard the word median before? Median. You all have. If you drive, you know what the hell the median is. What's the median in the road? Where is it?
Middle.
In the middle. So the median is the data point that's in the middle. We already know a different name for this. If I find the data point that's in the middle, what percentile is that?
50th.
50th. Yeah, so the median is just the number, the data point. Or let me say it like this, because you're right, it doesn't have to be a data point. The number in the middle of the data, it's got to be in order. So, for example, what's the median of 1, 2, 4, 9, 11? 4, I love it. And the symbol for median, it looks like a sample mean, X bar, that had a rough night. A little tilde over. It looks like its bar got squinched. Poor little dude. So that would be 4. That's the median. I like it. So what's the median of, if I have 4, 11, 12, and 29? What's the median?
11.5.
Say again, sorry?
11.5.
11.5, that's right. We talked about that before. So if there's an odd number of numbers, there is a middle number. If there's an even number of numbers, you're going to have to average 2 in the middle, right?
Yes.
Okay, maybe. Now, why the hell does median exist? Does anyone, you probably don't get a newspaper, right? I don't even get a newspaper anymore. I used to, old man Jeff. There are certain things that we discuss and we don't use the average. So let me give you an example. Sorry, go ahead. Is somebody talking? No, okay. It's just Jeff hearing things. So what if I'm going to start to work for a company and 4 people work at this company. And I'm going to work there with them. They're about to hire me. And somebody makes $38,000 a year, $40,000 a year, $42,000 a year, and then the boss makes $650,000 a year. Everybody with me? Roughly mimicking real life. And I asked them, how much money can I expect to make? And they tell me the average of those salaries. What is the average of those? I don't even.
Add them and divide them by 4.
That's right. 770 divided by 4 would be
192.50.
Well, thank you. So $192,500, because these were in thousands, right? If they tell me, if I say, hey, what can I expect to make working at this company? And they're like, well, the average is $192,500. I'm like, holy shit. Is that being honest?
No.
Is that a good thing to tell somebody just starting work? No. What's the median though? What would the median be?
41.
Yeah, it would be 41. You with me? 1, 2, 3, 4. So the median's right in the middle. 41,000. Is that a more appropriate thing to tell somebody?
Yes.
Yes. So salaries. Has anyone ever been to La Jolla? You ever visited La Jolla? I like to visit La Jolla, go to the beach, and then look at the houses that I probably will never even be invited into, you know. Oh. So when we discuss house prices, it's always median house price, or else the insane houses would overblow the idea. It wouldn't give me an accurate idea of what things are. Does that make sense? What do we call this kind of thing? What is this? What kind of data point is that? It's a certain name for it being way away.
Outlier.
Outlier. Which always reminds me of, there's a movie called Children of the Corn. They go, Outlander, but that might just be me. Outlier just means something that's doesn't follow the pattern of the rest of the data. So whenever you have an outlier, it's going to affect the mean much more than the median. If I made this, the mean is going to go crazy, right? The median, would the median change at all if I did that?
No.
Median doesn't give a shit, right? Yeah, like it, maybe. So that's why they both exist. Okay. One last thing. Notice, would either the median or the mean work with qualitative data? Let's bring back a definition from before.
Yes.
What kind of data is qualitative data?
Description.
Descriptive, right? Like hair colors. Can you find the average hair color?
No.
No. Can you find the average model car? How the hell? What is
No.
Ford plus Hyundai plus BMW divided by 3? What is that? I don't know. All right. So there is a measure of center that works with qualitative data. These work with only quantitative. So here's the third major measure of center. It works with numerical data too. It's called the mode. And the mode is the number that occurs, or not the number, Jeff, you just said, the data point that occurs the most. Did I spell it right? Is there 2 R's? Yeah. So for example, if I start collecting everybody, if I start writing down hair colors and I see blonde, I see another blonde, I see brown, I see bald, what would the modal hair color be of these 4 people?
Blonde.
Blonde. Okay. The mode would equal blonde. So it works with non-numerical data. The idea of a mode is to try to figure out, is the data clustering somewhere? So let's look at numerical data. So what if I had this 5, 6, 7, 7, 8? Obviously the mode is what?
7.
7. Ooh, what about if I had 5, 5, 6, 7, 7, 8? What would the mode be here? This is actually bimodal.
So it could be 5 and 7.
Exactly. And then we can have trimodal, but that's it. Past that, we're like, no, there's not really a mode. It's not really. So it could be unimodal, ooh, one mode, bimodal, trimodal, and beyond that, there isn't any. And of course, what if I had this? What's the mode of this data? 1, 4, 9, 11, 12. What's the mode? Does anything occur more than anything else?
Nothing.
Nope, so no mode. So there can be no mode, definitely. That's not that bad, right? It's pretty good. Okay. I think that's enough. What do you guys think? I think that's plenty. So if you want to, yeah, mode doesn't, one semester, somebody asked that question, I'm like, no, it doesn't. And somebody said, can we make one? I'm like, yeah, let's make one. So we made a symbol that semester for mode. But mode does not have a special symbol. So if you want to create one, you can. right? Make math your own. Let me know if you have any questions. Don't forget the quiz. You can start it right now if you want to. When is the quiz due?
Tomorrow at 9.
Tomorrow at 9 p.m. So you can start it anytime you want to, but once you start it, you have 50 minutes to get it done. If you have any technical difficulties, like if Canvas won't take it, email it to me and then keep trying to upload it. So then I know when you got it done. Is everybody with me? Don't turn it in like 8 hours later and I'm like, what? No. Okay, maybe. Or if anything else goes wrong, just try to email me. If your Wi-Fi completely shuts down, just get in touch with me as soon as you can. I understand. We're online. Things can happen. I totally understand that. But yeah, so you have time. All right, guys. Let me know if you need to hang out. Otherwise, you are free to go.
I just got a quick question.
Yes.
What kind of calculator do you recommend?
So as it states on the syllabus, I require you to have either an 82, 83, 84 TI, 82, 83, or 84.
Okay, copy. Just want to make sure. Thank you.
You're welcome. Anybody else? You guys all right?
Are we all caught up to 2.7 then today?
No.
Oh,
We just
because I
did,
heard you said- What
sorry?
section did we do today?
2.5.
So 3, 4, and 5 then. A little bit of,
Today we did 2, 3, 2, 4, 2, 5. Yes.
okay, just making sure.
I remember.
4, 5, 2, 3, 4, 5.
Oh, we keep track of that.
You're okay. Don't worry. It could be so much worse. Don't worry. You're okay. Don't worry. It's all good. We're right here with you. Everybody makes songs. Everybody okay? I'm going to head out if you guys are good. I'm going to get a late lunch.
I have a question.
Yes.
It's about the percentile.
Yes.
So I didn't get it. The how to get the like question 1. So like a first step, like 25% of like 12. How to calculate it? How to get that results?
25% is 0.25. Right? I'm going to give you the
0.25.
technical. I'm going to give you the technical way to do it, right? So 25% is once, twice, 0.25. And
Okay.
of means multiply. So it'd be 0.25 times 12.
0.25 times 12.
That's right.
Oh.
Make a percentage of decimal, you move the decimal back twice. And of means. Now, listen, 25%, isn't that just 1/4?
1/4.
A quarter. 25% is a quarter of something.
Yeah, it is.
And 1/4 of 12 is 3. Bam. So sometimes it's easier to make them into fractions, but you can do it either way.
Okay. So it is like percentile. So that's why like 100. 25 divided 100
by 100. Yes. That's why the decimal goes back twice. Yeah.
0.25, right? And the multiple the 12.
That's right.
Okay.
Because with percentages and fractions, of means multiply. Yes.
Okay, let me try it. So actually, I got a lot of wrong on my homework. So can I redo it and resubmit to you? Then you got
there's information about corrections. They're due by the day of the final, so you have time.
Okay.
So you correct anything, yeah.
So you're gonna like make it correct something wrong. I got wrong again. Maybe you can mark something
You can
wrong.
redo anything you got wrong. You can redo it and resubmit it. Yes. And the same. Yeah. Oh, I know, Jeanette. I'm sorry. I'm trying to get to your. It is. You have 50 minutes. 50. Yeah. So you open the quiz. You have 50 minutes. When you're done with the quiz, to be really honest, it doesn't matter what you type in the little box, but you can type time you're done and hit submit quiz. Then you scan your work and you turn it in where it says submit quiz 1 here. So you have to go to quiz 1 to get the quiz, and then you have to go to submit quiz to turn it in. Is that cool?
And you put the time in the comment section, right?
Yeah, you can actually write whatever the hell you want to. The thing is, if people don't hit submit quiz, on my side, I can't see which version of the quiz you got because there's more than one version of the quiz. So if you hit that submit quiz button, then I can see which version you got. So it kind of sucks when people forget to do that because then I can't be sure which one it is.
Thank you.
All right. Is that good, everybody? I'm going to head out if so.
Yep, thank you for your time.
Yeah, sure. All right, guys. I'll see you. Have a good long weekend. We're off Monday.
Okay, thank you.
Okay. Bye.